Okay.
Okay, here we are. So, hello everybody, and welcome to join this session. I'd say that this is a special community call because we are hosting our community call, the Capsule one, bi-weekly on Wednesday at this time, if I recall correctly. And today, I would like to bring you a brief introduction of what is Capsule, about the multi-tenancy in Kubernetes, and then also a demo of how to install Capsule on the major cloud providers. So Amazon AKS, Azure Kubernetes Service, AKS, and GKE, Google Cloud Kubernetes Engine. And we are going also to install Capsule locally on a Kubernetes cluster using Kind. But before proceeding, I would like to start a discussion of what is Capsule. So what is Capsule? It's a multi-tenant operator licensed Apache 2 that implements multi-tenancy in Kubernetes. And it's not a classic operator because, you know, with the operators, you're getting a lot of custom resource definitions. And from that, you're managing resources that are not so much trivial to use, like databases or anything else. Instead, Capsule is a sort of framework to build your own multi-tenancy, because we are going to see that there are so many options to implement multi-tenancy. And how can you use Capsule? Luckily, we got a lot of adopters. I'd say also a lot of contributors, and we are growing. So there are plenty of use cases. But keep in mind that the most famous and the most trivial, I'd say, is creating a public container as a service platform, a sort of Heroku in inverted commas, or eventually building your internal platform as a service. So a place where the developers can create namespaces, deploy their applications, and, you know, creating this platform for your own company or for internal customers of your company. Or rather, it could be used also to create a sort of managed Kubernetes service, although it's not managed, but we had the pleasure to work with Wargaming, and with them, we worked in the scenario of the bring your own device. So nodes that are joining a tenant and are getting just the workload of the tenant deployed over there, or whatever you want. I saw people that is using Capsule in several ways, and it's absolutely incredible because everything was started just like a game. You know, we started doing open source, and a lot of people saying, yeah, it's really interesting. May I help you with this feature, with this bug request, well, feature request and bug and so on and so forth. So right now, Capsule is really popular. And these are the most recent stats that we achieved because it's production grade since few months. Well, I'd say in the last year, because we got Max from Wargaming that presented Capsule at KubeCon 2021. It was a mesmerizing experience, although it was virtual because, you know, with the COVID and pandemic situation. But jokes apart, although pandemic is not a joke, production grade, it means that we just released 0.1.2 version with some nice features. We are consolidating our API, and it's incredible because we are getting more and more contributors, more likes or stargazers on GitHub, and we are trust. And this is absolutely incredible by companies that are using Capsule in production, and they are building products on top of that. Just to name few, we got Wargaming from Max Fedotov, we got NS Netherlands, we got BEDAC, University of Turin, a special hello to Jacopo Colonelli, a friend of mine that we presented Capsule along the Open Deep Health project. And just to provide a brief overview, Jacopo craft a platform for deep learning on Kubernetes using Capsule. And then we got also Fastweb, that is a cloud provider in Italy and is building, just released a public container as a service platform. And beside that, we have also mentioned on the Kubernetes documentation, the official one in the multi-tenancy section. I am really proud of that. And we just received also a specific topic, a specific channel in the Kubernetes Slack workspace. So if you haven't joined yet, please join Capsule so we can continue the discussion. You can get in touch with the maintainers. We can try to help you with whatever you want. So Capsule is the solution to address multi-tenancy in Kubernetes. So there is this dilemma. So what is the multi-tenancy dilemma? I would like to start with a joke because I'm Italian. You know, I do a lot of jokes. To all the people that know me, you know that I do a lot of jokes. But multi-tenancy is a way, especially in Kubernetes, to deploy multiple applications in the same cluster. In the end, what you're doing with namespaces is a sort of multi-tenancy, because you got your application that is living in the namespace full, then another application in namespace bar, and these applications can share just the namespace scoped resources like persistent volume claim, config maps, secrets, services, and so on and so forth. So this is just a joke, but when you start implementing multi-tenancy in Kubernetes, you say, with namespaces, we are good enough. We don't need any more else, but you're ending up with the second picture with full of cats that are putting E on top of each other. So it's a mess. So what are the basic resources that Kubernetes is offering to address the multi-tenancy? These are basic primitives, and I'm talking about the limit range, the network policy, resource quota, and obviously namespaces. With limit range, for example, you can say these pods must start with at minimum, at maximum, this amount of CPU and memory and storage and so on and so forth. Instead, with network policy, you are going to segregate the network. So you can say each namespace got a boundary, a network boundary. So it means that application in the namespace full cannot be contact or cannot contact the application in the namespace bar, and vice versa or vice versa, depending on how you pronounce that. I used to say vice versa because it's from Latin. So I'm from Italy, and that's the reason, you know. And then beside that, we got also the resource quota, and resource quota are really cool because in the end, you can create some boundaries in the application. Well, not the application, but on the resource consumption inside a namespace. So you can say that that namespace cannot consume more than 10 pods or 2 GB of memory, this amount of resources like persistent volume or storage and so on and so forth. So all these resources are orchestrated in namespaces. And how can you entitle user to use that namespace? Well, obviously using the RBAC, the role-based access control. So with that said, I'm saying that a user like Alice, that is the name that we are going to use through the demo and also in our documentation, Alice can be granted to access that namespaces using the role binding on that namespace. But obviously, this is not enough because we have to address several levels of multi-tenancy, because especially in the public scenarios, you have to be sure that the application is not able to perform privilege escalation, cannot create noises, you know, the noisy neighbor effects, or cannot allocate some specific node ports and so on and so forth. So it's a matter also of security. We already talked in this meetup, in the Kubernetes Multi-Tenancy meetup regarding security with Alessio from Classics. It was really interesting. So multi-tenancy and security play a role together. So after that, let's try to dissect the basic concepts of the multi-tenancy and also the tiering, because just to keep it simple, we can say that we got 3 tiers of multi-tenancy: the 1 cluster per app, 1 cluster per team, and the sharded cluster. So with the 1 cluster per app, well, you're ending up with a RAIN, a Kubernetes cluster just for your application. And so far so good, because you got your nodes, you're pretty sure that you don't have any side effect, you don't have any pod that is throttling the CPU or creating memory pressure. So it's perfect. It's like having your own villa and you're doing whatever you want. But obviously, this is really, really hard to manage because it's expensive. You can imagine, like, take the example of Netflix. So Netflix got a lot of microservices, thousands of microservices. You cannot create thousands of clusters. Well, you can do that, but it's your game then taking care of those clusters. But this approach is pretty common because in the end, also with the Capsule approach with cluster API or all the tools to spawn clusters, you can do that. But I'd say that the most used way in multi-tenancy, without Capsule obviously, is the 1 cluster per team. It means that we are a team, so we are responsible in creating several products. and we are managing our Kubernetes cluster. And that's great because in the end, it's like entitling people to be DevOps. So although I'm a software engineer, I'm doing my software, I have to take care of the cluster, of the production, so far so good. But you can imagine what could happen if we got multiple teams in a company, thousands of teams in a company. So each one is going to use a specific cluster setting or specific versions, and it could be a mess because you have to try a way to standardize everything. So this can sound the reasonable choice, but from the operational perspective, it's really hard. I'm not saying that it's impossible. You can do that because the next step that we're going to see is the shared cluster. And I don't want to say that the shared cluster is always the win-win solution. It really depends. And that's the reason why I'm saying it really depends. And I'm trying to explain you all the payoffs. And in the shared cluster, that's the approach offered by Capsule that Capsule is covering. In the end, we are ending up with a cluster with a tenant abstraction. So what is the tenant? The tenant in the Capsule terminology is a collection of namespaces that are belonging to a namespace, well, a tenant owner. And this tenant owner can just operate over those namespaces. So in the end, it's like having a sort of slice of your Kubernetes cluster where you can do whatever you want, obviously with some policies, because in the end, Capsule provides some policy rules enforcement. There is a policy engine. So before getting serious, because I wasn't serious enough, I would like just to make a final joke. So no more memes, trust me. One cluster to rule them all, one tenant to find them, one kube company to bring them all, and in the darkness bind them. You know this quotation, this quote? Well, it's from the Lord of the Rings, but no, it was just joking, the Lord of the Clusters. But keep in mind that in the end, this is what Capsule is doing, because you're ending up with just a single cluster. You're creating boundaries for the tenants, and you can try to rule them over. So without any problem or any downside of creating a wall regarding the clusters. But stop joking, I promise. How Capsule works. So I'd say that we got 4 components: user organization, webhooks, and owner reference, and CRDs. So since we are talking about multi-tenancy, it means that everything starts from the authentication. So it means that there is a user that is authenticated to the Kubernetes cluster and would like to perform operations. So how can we interact with users? We all know, and in case you don't know, I'm going to explain you, that a user is a resource in Kubernetes, but it doesn't exist. If you try to issue kubectl get users, you don't get anything. So in the end, a user is just an authenticated client that is connecting to the API server. And this client got a username and some groups. And you can achieve that using 2 ways, mostly. Using the TLS client certificates, so generating certificates from the CA of Kubernetes, and from that, creating the user and the common name, the groups, and blah, 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 blah. Or eventually using the OpenID Connect. So you got an identity provider, and starting from that, the API server is connecting to the identity provider, ensuring that the token is the correct one, and there is a lot of moving parts. So keep in mind that you can use certificates or OIDC, OpenID Connect, identity provider. So it means that what is doing Capsule, in the end, we are connecting to the API server, we are intercepting the request from a user and saying, okay, you can perform this request or not, or eventually mutating that. Let's imagine I'm Alice, I got my tenant, I got my namespaces. What happens if I try to delete a namespace that is not owned by me? Obviously, Capsule is blocking that, although there is already the RBAC doing that. But just to bring you an example, a real example of what is doing Capsule. So we are able to intercept the request. From the request, we are getting the user, and from the user, we are able to say, you're part of this tenant and you can do these options, well, these actions or not. Keep in mind that with Capsule, we are just granting one single cluster role to the tenant owners, and it's the Capsule namespace provisioner. It means that any tenant owner can create namespace. Besides that, obviously, there are so many moving parts, and Kubernetes is great because thanks to CRDs and dynamic admission controllers, you can extend Kubernetes without rebuilding it or recompiling it. And it's absolutely mesmerizing, it's credible, and I think this is the reason why Kubernetes won the war between container orchestrators. So with that said, Capsule is totally relying on webhooks, the dynamic dimension controllers that are mutating and validating webhooks. So essentially the validation webhook is say, I would like to create a namespace. Capsule is checking that request that has been made by Alice, check the count of the namespace, and starting from that saying, okay, you can do that, or no, you cannot do that. And this can be also done using mutating webhooks. So it means that when you create the namespace, we are editing the request, so adding some fields, adding some options in order to create a sort of boundary, a connection between the tenant and the namespace. Currently, Capsule, keep in mind that got this policy engine, everything is working smooth because we can limit network policies, resource quota, we can do a lot of stuff. But we got also customers and users that are using along with Kyverno and open policy agents. So we are not mutually exclusive. It means that you can use your policy engine to add further policies to your multi-tenant environment. But how a tenant or a how a namespace can be added to a tenant, this can be done using the owner reference and the controller reference. So if you recall, I just told you that with the mutating, we can edit the requests that are sent to the API server, to the Kubernetes API server, and same we're doing with the namespace. So when Alice that got a tenant create a namespace, that namespace is going to be edited. We are going to add new field that is the controller and the owner reference. And it's the basic concept that we are using with the pods, because in the end, when you spawn a pod, the pod is controlled by a replica set, and the replica set is controlled by deployment. There is this chain, and we are reusing the same concepts by Kubernetes. And I think this is the success behind Capsule, because in the end, what we're doing is essentially keeping the same developer experience that you can face on any Kubernetes cluster. So when you create namespace, the namespace is attached to the tenant using the owner reference and the controller reference. It means that you are creating a sort of hat, a sort of collector of namespaces. But obviously, how can I define a tenant? The tenant can be defined using the CRDs, the custom resource definitions. So the CRDs is open API free on top of the API server. So you can extend the API server, adding further types to manage. So the single resource, additional resource that we are installing with Capsule, beside the Capsule configuration, is the tenant. So it means that I'm the cluster administrator. I would like to provide a tenant to Alice. I just create the resource, and from that resource, I'm pointing to the Alice user, and Alice just need to issue the command kubectl create namespace solar production. End of the story. We don't need any plugin, any extra binary. You don't have to study a different API server because everything is Kubernetes vanilla. So it means that you don't have to start scratching documentation, scratching the code to understand everything. Pure Kubernetes experience without opening a ticket to get your namespace provisioned. And with that said, I think that we can start with the demo. Just a few seconds because I need the AC because it's getting hot here. In the meanwhile, do we have any question here?
For now, not a question, but I can tell from the chat that much of the people are using AKS.